Hello! Welcome to this webinar on the benefits of LTO battery technology. When we talk about batteries, the objectives seem clear. Store the maximum energy in the minimum space at the lowest possible cost. So it's often all about energy density and euros per kilowatt hour. Toshiba is the leading manufacturer of LTO battery cells, but they actually have a lower energy density than other lithium-ion chemistries and are therefore correspondingly more expensive in relation to their capacity. So what are we doing here? Well, let me and my colleagues explain why LTO batteries are advantageous in so-called heavy-duty applications. But what do we mean when we talk about heavy-duty applications? Here is an example of an article about a Tesla that drove 2 million kilometers. That sounds like heavy duty at first. But let's look at what that means for the battery. Over the entire distance, the battery was replaced 3 times. This means that each kilogram of the battery saw an energy throughput of 158 kilowatt-hour over its lifetime. For an electric car, this is certainly an extremely high value. Now, let's compare this with another application, in this case a regional train. In such a train, the battery replaces the diesel generators in order to drive emission-free, even in areas without overhead lines. When the train returns to sectors with overhead lines, the battery is recharged very quickly several times a day. Over its lifetime, 1 kilogram of this battery is charged and discharged with around 2000 kilowatt hours. So an energy throughput more than 10 times higher than this extreme example of an electric car. And this is what we call heavy duty. In an electric car, the decisive factor is the range. In other words, the energy density of the battery. Even if this range is rarely used, maybe only for the annual trip on holiday. In fact, the battery is often charged only once a week, and then quite slowly, usually overnight. Even at fast chargers, it takes about 45 minutes. It is a little different with electric ferries that cross a river, lake or fjord 20 times a day, for example. Here too, you can install a battery with the largest possible capacity that cover all the journeys and then recharge it overnight. But you can also install a much smaller battery that is then recharged at every stop. This saves space and cost. For the battery, however, this means that it has to be charged very quickly and very often. And that is exactly what is possible with LTO batteries. Sven, could you explain why it is usually cheaper to use LTO batteries in such heavy-duty applications?
Sure. Toshiba SCiB cells are built to last. They are designed to provide a much longer lifetime compared to other battery chemistries such as NMC, LFP or lead acid. Industrial and heavy-duty applications typically have a demanding load profile, which needs to be sustained over a decade or even multiple decades. Due to the superior lifetime of SCiB, battery replacements can be minimized. At the end of the day, what counts is the total running cost, which is also called total cost of ownership or short TCO. Even though the initial cost of LTO cells may be higher compared to other battery chemistries, each battery replacement drives up the running cost. In industrial and heavy-duty applications, this leads to a lower TCO when using SCiB. To further reduce the TCO, the battery capacity can be reduced by SCiB. To illustrate this point, I'd like to show a concrete example for an automated guided vehicle. Let's assume a typical run takes 60 seconds and consumes 4 watt-hours. Let's further assume that there are 1,200 runs per day, which require 4.8 kilowatt-hours of energy in total. Due to its high cycle lifetime and quick charging capability, SCiB can be recharged much more often than an NMC battery. By this, the battery capacity can be reduced by factor 10, which reduces the weight by factor 4 and the cell cost by factor 3. If we then consider that the lifetime of the SCiB battery will be about double compared to the NMC battery, the TCO of SCiB will be 6 times lower than NMC. Further details will be explained by my colleague Yamamoto-san. Yamamoto-san, over to you.
Thank you, Sven. Let me explain the technical reasons why SCiB offers a superior lifespan compared to other battery chemistries. The SCiB was introduced in 2011 as a lithium-ion battery with unique properties. The properties of electrode materials in the battery significantly affect its performance. And SCiB features the anode using lithium titanium oxide (LTO). Leveraging Toshiba's extensive battery technology and advanced manufacturing capabilities, we have successfully mass production of high-quality batteries utilizing LTO. The superior performance of SCiB contribute to both a reduced total cost of ownership and the sustainability of the electric applications. Electrification can reduce environmental impact by lowering CO2 emissions from reduced fossil fuel combustion. However, to truly benefit the environment, the batteries must have a long lifespan. The frequent replacement worsens the environmental impact through increasing energy consumption and waste generation. Therefore, long-lasting batteries are essential for the sustainability. So before explaining about the LTO chemistry, let's examine the general degradation mechanisms of lithium-ion batteries. The degradation can occur through the two main anode-related mechanisms, physical and chemical. In physical, the mechanical stress can cause the electrode to collapse, especially during the expansion and contraction of the electrode during charge and discharge cycles. The conventional lithium-ion batteries with graphite anode are particularly sensitive to this issue. This can lead to disconnection with the electrode, then isolating electric passes. In chemical, high electrode reactivity can cause side reactions that consume lithium ion and decompose the electrolyte. This reduces the number of usable lithium ions and directly decreases battery's capacity. The LTO anode in SCiB helps reduction these degradation mechanisms. Lithium titanium oxide has a stable spinel crystalline structure with strong titanium and oxide bonds, resulting in almost no volume change during charge and discharge. In contrast, a graphite anode can swell by over 10%, leading to particle and electrode cracking. The LTO anode avoids such issues, allowing for a wider charge and discharge range without physical degradation. The cycle life performance of SCiB is outstanding, enduring more than 20,000 charge and discharge cycles. Even under severe conditions like a fully charge and discharge or at a 5C rate and or 35 degrees C environments. This means that application with SCiB can be charged and discharged fully in extremely short time, yet SCiB still managed to show superior lifespan. Another key advantage of LTO anode is their low reactivity to the side reaction. The LTO can operate within the electrolyte stability, unlike graphite, which has a higher potential for side reaction that decompose the electrolyte and consume lithium ion in the battery. The figure on the right side illustrates the typical chemical potential range of various active material versus lithium metal reaction during charge and discharge in the battery. The LTO can charge and discharge within the stability electrochemical potential window of the electrolyte. On the other hand, the graphite shows a lower potential towards electrolyte stability windows. This means the reactivity to side reaction of graphite anode is quite high. Additionally, the potential difference between the graphite and lithium is narrow. The absence of this potential gap causes lithium plating on the anode surface under high charge current or low temperature. The plated lithium, also known as lithium dendrite, cannot only reduce the battery capacity but also increase the safety risks, such as an internal short circuit. The large potential difference between LTO and lithium reaction reduces the risks of lithium plating and dendrite formation, enhancing both capacity retention and safety. In summary, the combination of LTO's chemical and physical advantage enables SCiB to deliver a superior lifespan and performance under demanding conditions, making it ideal for heavy-duty applications. SCiB not only reduces the TCO, but also offers additional unique benefit. We look forward to discussing your lithium-ion battery requirements and offering our best solutions. Back to you, Sven.
Thank you, Yamamoto-san. The cell lineup is divided into high-power cells on the left and high-energy cells on the right. High-power cells are optimized for maximum input and output power. High-energy cells are optimized for maximum energy density. The 20 Ah HP cell combines the best of both worlds. It offers a high power density and a high energy density. All cells are shipped in a prismatic form factor. There are only two can sizes. The 2.9 Ah high power cell is the only cell which comes in the small form factor. All other cells use the same big can and are hence interchangeable in the same module. Speaking of modules, Toshiba offers a 2P12S module based on the big cell can. It comprises 24 cells and a CMU board. CMU stands for Cell Monitoring Unit. It measures the voltage and temperatures of the cells and provides this information to the battery management unit via a CAN bus. The cells are housed in a polycarbonate casing. Toshiba also offers other components such as a BMU, current sensor, and contactors. Multiple modules can be combined like Lego bricks into larger energy storage systems. As long as no water cooling is required, the Toshiba 2P12S modules are a cost-effective way to build a battery system from standard components. The SCiB industrial pack has been designed to be a drop-in replacement for lead-acid batteries in industrial applications such as AGVs or warehouse shuttles. These packs are complete batteries and contain, for example, a BMU, contactors, sensors, and a fuse. A single SCiB industrial pack can be used for 24-volt applications. Two packs can be connected in parallel to double the capacity from 556 watt-hours to 1.1 kilowatt-hour. Another option is to connect two packs in series in order to build a 48-volt system. The SCiB industrial pack is an easy entry point into the SCiB world. One of the prime use cases for SCiB LTO batteries is the usage in traction batteries for railway due to its high safety, long lifetime, and high input-output currents. In this case study, a 200 kWh liquid-cooled battery with 23 Ah SCiB LTO cells has been used. In a typical use case, 35% of the capacity is used, but in some rare cases, the depth of discharge can be as high as 85%. The train is operated for over 18 hours per day and 320 days per year. The maximum current is around 3 to 4 C in discharge direction and around 4 to 5 C in charge direction. During the simulated operation of 15 years, the energy throughput amounts to over 4 gigawatt hours. The result of the lifetime simulation is that the remaining capacity after 15 years is still around 85%, which is equivalent to about 21,000 equivalent full cycles. Damen Shipyards built an electric tugboat called Sparky, which operates in the port of Auckland in New Zealand since 2022. The tugboat has been designed for the lowest total cost of ownership over its lifetime. A 2.8 megawatt-hour battery system is installed on the vessel, which has been designed for heavy-duty applications and high-power operations. It allows for a peak power of 10 megawatt, which enables the tugboat to achieve a bollard pull of up to 70 tons. The batteries support fast charging from 20% SOC to 90% SOC in just about 90 minutes. Even though the usage profile is demanding, lifetime estimations show that one set of batteries can cover the entire 25-year lifetime of the tugboat. Thanks to these and other innovative features, the vessel won the prestigious Tug of the Year award in 2022. Toshiba conducted a case study for a mining hole truck. In this study, a liquid-cooled 920 kWh battery using 20 Ah high-power cells was used. The load profile is quite challenging. About half of the capacity is used per cycle, which takes about 30 minutes. There are 38 cycles per day, which amounts to 19 hours of operation in total. The assumption is that the truck operates 365 days per year. The consumed energy during the trip will be recharged in just 3 minutes with over 8 megawatt. Within 20 years of operation, the total energy throughput is almost 125 gigawatt hours. According to Toshiba lifetime simulation, the remaining capacity after 20 years of operation is still 83%. This is equivalent to 138,000 equivalent full cycles. We did a comparison with 87 commercially available LFP cells, based on publicly available information. The result of this comparison is that no battery replacement is necessary with SCiB during 20 years of operation, whereas up to 20 battery replacements are needed with LFP batteries. The total cost of ownership of the SCiB-based solution is 4 to 16 times lower compared to the LFP-based solutions. Last but not least, the SCiB-based solution produced 9 to 64 times less waste in tons. Normet is using the 23 Ah SCiB LTO cell in their M-series mining vehicles. A liquid-cooled 90 kWh battery is used as a traction battery. To simulate the lifetime of the battery, the following typical load profile has been assumed. Up to 89% of the battery capacity is used per cycle. There are 7 cycles per day, which amounts to 16 hours of operation in total. There are 300 operational days per year. Between each cycle, the battery will be recharged with 155 kilowatt. During 15 years of operation, the total energy throughput is still 2.5 gigawatt hours. The result of the lifetime simulation is that the remaining capacity after 15 years is still 82%. This is equivalent to 28,000 equivalent full cycles. We compared the result with 87 commercially available LFP cells. For the estimation, we used publicly available data and made reasonable assumptions. The result of the comparison is that no battery replacement is necessary within 15 years with SCiB LTO cells, whereas 1 to 4 replacements are needed with LFP cells. This results in an up to 4.5 times lower total cost of ownership and 2 to 14 times less battery waste in tons. Further applications will now be explained by Sacha.
Thank you, Sven. Today, I would like to show you the advantages of LTO batteries using two practical application examples: hybrid generators and hybrid lifting cranes. The focus here is on the potential savings and increased efficiency offered by this battery technology. LTO batteries are often used in hybrid generators that have to reliably supply energy under extreme conditions, for example in mining, on construction sites, or at outdoor events. The advantage: these generators do not run at full power all the time. Instead, they only switch to full power when more energy is needed for a short time. This is where the LTO battery comes into play. Not only do they require lower capacities compared to conventional systems, we are talking about a factor of 3 or higher here, they can supply the required energy so quickly that they cover these peaks in demand and thus relieve the generator, allowing you to use smaller and more economical models and thus significantly reduce diesel consumption. Comparing LTO with, for example, LFP batteries for such an application, a significant difference lies in the service life and the costs. LTO batteries are characterized by a significantly longer service life. LTO offers up to 20,000 charging cycles compared to the approximately 2,000 charging cycles of LFP batteries. This higher number of cycles means that LTO batteries are more reliable and sustainable in the long term. However, these advantages are reflected in higher acquisition costs. Despite this higher initial investment, a comparison of the total costs of ownership, TCO, over 9 years shows that LTO with a TCO of 45 is more economical overall than LFP with a TCO of 180, where you have to replace the battery every 4 years. Hybrid lifting cranes are another exciting area of application, for example in harbors. Traditional cranes run permanently on diesel generators, consume large amounts of fuel, and cause high energy costs. Hybrid lifting cranes, on the other hand, are also equipped with LTO batteries. The battery supplies the energy for lifting and moving loads and enables the generator to be operated at an optimum power level instead of constantly running at maximum level. This saves fuel and reduces emissions. One key advantage is the recuperation capability of LTO batteries. When loads are lowered, kinetic energy is released. This energy can be fed directly back into the battery and used for the next lift. This significantly increases energy efficiency and further reduces operating costs. Another technical highlight is that the use of batteries means that expensive grid connections with high connected loads can be avoided. Instead of 100 or 400 kV, 10 or 40 kV is completely sufficient, which drastically reduces investment costs. In addition to these functional advantages, LTO batteries also score points for their exceptionally long service life. They typically achieve 20,000 charging cycles, even with intense use. By comparison, LFP batteries only manage around 2,000 charging cycles and therefore have to be replaced much more frequently, a costly disadvantage. To summarize, LTO batteries not only offer efficiency advantages in operation, but also sustainably lower the total cost of ownership and reduce emissions. Their long service life and ability to provide and absorb energy quickly make them a key technology for modern energy systems. Coming to electrified bus fleets and the use of LTO batteries. The electrification of a bus fleet presents operators with a wide range of challenges. It is not just a matter of replacing an existing diesel bus with an electric bus. This would not only be economically unviable, but in the worst-case scenario could lead to the non-fulfillment of the basic task of running the public transport service. Operators of electrified bus fleets have clear requirements to ensure smooth and efficient public transport. One of the key requirements is high reliability and availability. The buses must be operational at all times, which is why durable, robust, and low-maintenance systems are essential. Short charging times and high energy efficiency also play a decisive role. In order to keep to the timetable and minimize downtimes, the vehicles must be charged quickly. At the same time, efficient energy consumption reduces operating costs. Another important aspect is the long service life of the batteries under high loads. As the buses undergo intensive charging and discharging cycles on a daily basis, the energy storage system must function reliably even after years of use, even with frequent rapid charging. Safety and environmental aspects must not be ignored. The technologies used must meet strict safety standards and at the same time be environmentally friendly in order to reduce CO2 emissions and minimize the ecological footprint. Finally, flexibility is a decisive criterion. Different deployment scenarios require adaptable technologies. From short inner city routes to longer intercity connections, the vehicles must be versatile in order to fulfill the different requirements. LTO batteries are the optimal solution for various applications in public transport. But how exactly do they fulfill the requirements of operators? Let's take a closer look at their possible applications. Let's start with trolleybuses. These are often connected to overhead lines throughout, but require batteries for sections without a power supply, for example during construction sites or line interruptions. LTO batteries offer a decisive strength here. They can be charged extremely quickly and can be fully recharged during the short time under the overhead line. Their long service life due to low degradation, high cycle stability, and wide SOC range also reduces maintenance costs and increases vehicle availability. Another area of application is opportunity charging buses. These vehicles charge their batteries at defined stops within a few minutes so that long charging breaks can be avoided. This is where the special properties of LTO batteries come into play. They are characterized by a significantly higher charging speed of up to 5C and are suitable for frequent charging and discharging due to their special chemistry. In addition, their high energy density results in a lower vehicle weight and therefore a higher payload. LTO batteries also play a decisive role in hydrogen buses, this time as a buffer. As hydrogen buses generate electrical energy from fuel cells, they require batteries to cushion load peaks and sudden energy requirements. Thanks to their high power density, LTO batteries can supply or absorb energy at lightning speed thanks to their high C rates of up to 20C, thus relieving the load on the fuel cell and extending its service life. LTO batteries also offer further advantages. They are particularly safe due to their high thermal stability and low risk of overheating. They function reliably at extreme temperatures, a major advantage in both hot and cold climates. And finally, they score points when it comes to sustainability. Their long service life reduces the need for replacement batteries and thus minimizes the ecological footprint. To summarize, LTO batteries offer an innovative and sustainable solution for public transport, efficient, robust, and future-proof. That's it from my side. Volker, let's get back to you again.
Let me conclude by summarizing a few points from this webinar. In many applications, fast charging, long life, high performance and safety are the decisive factors for choosing the best technology. The ability to reduce the size of the battery and avoid replacements over lifetime are more important for the total costs of ownership than energy density. LTO is the most powerful, robust, and safest lithium-ion technology available and offers many advantages for heavy-duty applications. Toshiba is the leading manufacturer of LTO batteries. And we are already working on the next generation technology, niobium titanium oxide, or NTO for short, will offer the same advantages while increasing energy density by 50%. SCiB NB is already being successfully tested in prototypes in field trials. So stay tuned. We would be very happy to receive feedback and are happy to answer your questions. SCiB LTO batteries, built to last.